Hi, guys, and welcome back to another episode of Women in Math and STEM, where our mission is to reach out to as many professionals, aspiring professionals, students, whatever you name it. We try to reach out to them, who essentially support the initiative of bringing more women and young girls into the STEM field. So, with that being said, as always, feel free to open up the description or transcript to better follow along, and I hope you enjoyed this episode. Hello, and thank you so much for coming to the call today and speaking with me. Just to sort of start off, do you mind introducing yourself and sort of walking us through your math and physics journey, and especially what particularly initially sparked your field or sparked your interest in these fields?
Sure. Thank you for having me in the first place. So my name is Badis. I'm from Tunisia and I'm a first year student at the University of Chicago right now. I'm studying math and physics, hopefully concentrating in theoretical physics, high energy theory, probably string theory or quantum field theory. And to put it briefly, my interest started because it's probably the thing, like the only thing that I enjoy that I'm good at the same time. If we were to say it like that. But to give a better answer, probably started from some mix of interest in philosophy, religion, numbers that just came together and introduced me to the field of physics. Because at some point back home, we don't really study physics. You only start with math up to some level. So I got introduced to this and I started looking into it, and then I started getting into mechanics. And for the first time, I got what it meant that physics actually described the world in equations. I always heard it, but I never got what it meant. So yeah, I found that very interesting, and now I'm here.
I think you mentioned that you have a concentration in, I think it was high energy and quantum theory.
Uh, yeah, we don't really do concentrations here. I meant that's my focus, or that's what I'm intending to pursue as I go forward. It's in high energy theory, particularly string and quantum field theory, hopefully.
Sounds good. I was just wondering what got you specifically interested in those focuses out of like everything you could have been or you could have done in physics.
This is a harder question because it seems like I know, but I don't actually know most of the stuff in quantum field theory. But I think the way that I got introduced to physics and math in the first place was by kind of following the fundamentals. I was interested in the fundamentals of existence, of like uh, if there is a God or not, the beginning of the universe, uh, evolution, like biological evolution, and it just felt normal to me that when I get into physics, I will study like the most fundamental, let's say, the smallest. Although it kind of for everyone, I think for most people, it starts with being interested in the biggest because I thought that in the pursuit for truth, I'll be looking in astronomy and cosmology, but then I ended up in the smallest.
Sounds good. I was also wondering, as a physics student, what has been some of your most memorable or rewarding experiences?
Mm, I think I think it's easy to say that the public public recognition would be very memorable, but for many people, at least for me, it's actually not the public recognition as much as it's like getting deep into the theory, getting stuff that at some point you used to look at and say, what is that? If you ever look at any quantum mechanics book or paper and you see all those like brackets looking very weird, all the ties for the wave function, and I used to think that the day I understand what that means would be like a very happy day for me. And I get to live the day by the day now studying that. And understanding what it means, and I actually recall on that every now and then and say, "Oh, that's nice. I'm understanding what I've always wanted to get." Because I I was passionate about it. I was interested in getting it, but definitely as a third grader, you don't know what the wave function is.
Sounds good. And I was also wondering, since you said that like sometimes like it takes a long time to understand things, I was wondering what you do when you encounter a very difficult question that may not be so easy to understand at first glance.
Yeah, yeah, it's definitely. I don't really think it's ever easy for anyone to pick up stuff, especially when you're doing it on your own. Sometimes you have to do it. There's not always teachers or mentors, professors around, or maybe that's the environment you grew up in or you come from. So yeah, it's hard in some way or the other for everyone. For me, I try to diversify resources. I'm thankful for the internet, uh, the Stack Exchange. There's lectures online. So I just go around here and there. It happened that sometimes I generally do not get the answer anyway. So I fight the intimidation and email professor. It it works out of 100 times, but it works sometimes.
Sounds good. And then I was also wondering, as a physics student, what has been some of your most favorite or most interesting classes you've taken or concepts you've learned?
Sure. Well, as I mentioned earlier, I think the most, let's say, surprising thing is mechanics as I started, and 'cause that's my first encounter with actually describing the real world in terms of math equations. No, that's like paradigm shift, is it? Because physics before that was, oh, this is a magnet and positive pole, it's North Pole, South Pole, whatever. But then you start actually doing equations, even if you start with algebra, but it starts getting nice. But now at this point, uh, definitely you start doing that, and if you're passionate, I was, so I started looking into how stuff looks like, and I think the happiest moment was starting to actually learn the math behind quantum, like quantum mechanics. That's probably what every person who hears physics thinks of right now.
And then I was also just curious about if there's any skill sets or just like qualities a person should have that would make them better or particularly good at studying physics.
Sure. Uh, well, one thing to start with is that sometimes hardships come from not having the prerequisites. Actually, many, if not most of the times, you don't realize that you're missing the prerequisites. For example, I at some point I picked up a general relativity book and I started going through it, and I definitely had to stop way more than when I picked up, let's say, Taylor the mechanics book, because I missed the background, the math background. I was not solid on that. So sometimes the hardships come from not knowing or not having the prerequisites. So maybe a good thing would be to go out or go on the internet and ask what the prerequisites for some topic are before you get in. This on the side, but some qualities I think every physicist or mathematician that we hear of had enough persistence and worked hard enough, probably when no one else was, to get to that point. Yeah, I think persistence, insisting on understanding the thing, because if you don't and you let it go, but by the time there will be many gaps in your knowledge, which is not perhaps the most optimal thing to have.
Sounds good. And then I was just wondering, sort of to end off, if you had any pieces of advice for high school students who are interested in possibly pursuing a career in physics or majoring in physics in the future.
Sure. My idea is that, well, to make it clear, I'm not a physicist yet. I'm getting there, hopefully. So my idea is that I believe I'll give this for students overall, then I'll give it for girls. For generally for students, I think you should keep in mind that it, to be honest, it's not meant to be easy. This is not, if you're following physics, this is not an easy career path. You will have to learn a lot, you have to go deep in many topics, and you can make it as easy as you want to if you actually love it and decide to devote time for it. It takes time. If you need, like many of the very successful people that I got to talk to here when I came to Chicago about the QFT, quantum field theory class, they said the first time you encounter QFT will probably not be the time that you understand it. You need to take a QFT class, go think about it, probably retake it when you go to grad school or reread the QFT textbook, maybe a second, maybe a third one, read papers, and then you probably will start building your own intuition. And this intuition that you build about the topic like QFT, you also need the similar intuition when you're doing mechanics, when you're doing E&M. And it takes time. It takes time for information to sink in, for a human to develop intuition about a new set of information. So give it time, be be persistent, never give up, and realize that this is a path that not many people follow. If you're lucky enough to be able to follow it, then you should make the most out of it. And for girls in particular, I think I mean, we used to, or back in the day, it used to be a problem that the girls go into this kind of man-dominated field, male-dominated field. But ever since there's many female physicists who are doing great work that we don't particularly hear about right now, or many mathematicians or just many scientists overall. Sabrina Pastersky, Lisa Randall, uh, Maria Mirzakhani, I believe. I mean, there back in the day, there are many physicists, women or mathematicians, women that are doing great work, and you can be one of them. I believe that if you put in the hard work, you will make it either way. I hope it gets better. I hope everyone gets the same opportunity to shine in the field. But for everyone, this field in particular is about not giving up and being persistent. Yeah.
Okay, thank you so much. It was absolutely amazing talking to you. Thank you.